So this is lesson 122 in Algebra 2 called Laws of Logarithms, Intersection of Sets and the Union of Sets. The law of logarithms we've already kind of gone over in previous lessons. And law of logarithms basically is the whole idea that when you're given log of x plus the log of 3x, that means that with the plus sign, when we want to make it into just one log and combine and actually add these, we get the log of x times 3x. So you multiply. Okay, so notice what happened here. We went from two logs to add those together into one log, and when we did that, we multiply. And the opposite is also true. When we want to separate these two, it will turn back into that there. And we did the same with division, where we had log of, let's give it a base, of 3 over 2, and if we wanted to split that up into two logs, we'd write it as a log base 3 of 3 minus log base 3 of 2. And if we wanted to go the other way and make it into one log, we do that. So that's pretty much all they're doing in that one little section on laws of logarithms. Alright, so intersection of sets, union of sets, and Venn diagrams. Gosh, they used to teach this back in elementary school. I don't know if they still do or not. So if this is familiar to you, great. If it's not, it's really simple, so you shouldn't have any problem with it. But when we have sets, and we're going to talk about these sets as being this circle here. So the sets in this circle are all those numbers, including 15 and 17. And the sets in this circle are all those numbers, including 15 and 17. This big box here is called the universal set, and it's basically the universe. It's the one huge group of numbers that we have there, and then we start looking at that universal set and start picking numbers out of it. So if I look in the universal set and I just want these two numbers, well, there I made a circle. Those two numbers are in my set. Alright, so let's look at intersection. An intersection of sets, and we're calling this set A and this set B. Let me make my pen a little bigger here. Okay, so that's set A and that's set B. Okay, so that means this circle full of numbers is A, this circle full of numbers is B. Alright, and that's all I'm going to refer to those sets as, named A and B. Well, an intersection means, or it has a symbol that looks like this, an upside down U, and let me get my pen at some decent colors here. Okay, so an intersection set looks like that. So if I say what numbers or what elements are in A intersects B, that means which numbers are in both A and B. And it would be those numbers right there. So if I wanted to actually write that out symbolically, I would do that. Okay, so I've got my A intersects B at equals the set 15 and 17. If I didn't have a drawing, and let's say that I just had a list of numbers. So I had A equals the set 1, 2, 3, 4, 5. Alright, so we're not even looking at the picture right now. And B has the numbers. Had those numbers. And I wanted to find out what A intersects B is. I would look at each set and pick the numbers that are common to both. So that would equal the set 2, 3, because those are the only numbers that are common to both. So you can look at it pictorially and look at it here and see two sets and see what's common to both. Or you can look at a set of numbers here. Now notice I've got a 2 and a 2 here. I only write at one time. And the 3, I only write at one time. I don't write all of the numbers because I'm just looking at which numbers are common to both of those. All right, so the other part of this is the union of sets. So let's get rid of all that. And the union of sets is made with a symbol that kind of looks like the letter U. It is just a symbol. It isn't a U. It isn't anything in Greek or Latin. It's just that symbol that looks like that. And what that means is I want to know all of the members in both sets. So if I looked at that picture and I said, what is A union B? It would be everything in A and everything in B that I would list. And if they gave you a drawing and wanted you to shade it, you would shade it real prettily like that. If they gave you A equals the set 0, 1, 2, 3, and they gave you B equals the set 4, 5, 6, 7. Let's put a 3 in there. Okay, so what they're asking for is the union. What is common to all of them? So it would be the set 0, 1, 2, 3, 4, 5, 6, 7. Okay, so it would be everything. All right, that's pretty much it. The only other thing I want to kind of at least mention to you is what is called a Venn diagram. And Venn is spelled with 2 N's. And that's what this is. It's just a diagram of sets, how we can draw our sets there. So let's go ahead and look at one of the examples here, the last example, 122.3. I'm going to pull that up here if I can grab it. There we go. All right, so bottom of page 495, it says, the circles contain the members of sets A, B, and C as indicated. Designate the areas that represent. So designate, go ahead and shade. Represent A intersects B. A intersects B. What do they have in common with each other? All of the area inside that right there. All right, they also want to know the B part of it, B unions C. B union C, then that includes everything in B and everything in C. Okay, so let's get rid of all that stuff. And the last one says B intersects C. Well, where does B intersect C? What do they have in common? Right there. All of that. Okay, now the key thing is this here is also in A, but that doesn't matter. It's saying what does B and C have in common? We don't even care about A. Okay, so you just shade that. And that is it for lesson 122 in Algebra 2.